Hello everyone and welcome back to the another video where I'm gonna cover a very fundamental concept of a data analytics platform which is known as Lakehouse. You guys would have heard this word a lot, right? And I just wanted to understand by going inside the depth of this architecture to understand how actually this works, right? You have understand the definition of Lakehouse is it combines the power of data warehouse as well as the data lake, right? Data warehouse, which is supposed to, store the large volume of structured data, whereas the data lake is defined or created to store the semi-structured and the unstructured data. Whereas the lake house combines the power of a data warehouse as well as a data lake, along with providing all the transactional related feature which any relational database provides. This is what the lake house is. Right. So there are the various data analytics platform which uses this lakehouse as a lakehouse architecture to store the data. To name few like Databricks, Fabric, right? If you just look at the Databricks, this is the main diagram which I really like. If you just see, which actually gives you the pretty much simple explanation how this lake house architecture actually get evolved over the period of time. Here you can see on the left side data warehouse where the structured database, the structured data with the help of an ETL, which is extract, transform, and load into the data warehouse, and then the data visualization tool like Power BI or Tableau or Looker can be, interact with the warehouse and generates a report, whatever you want, right? But that was awesome until we don't have a lot of unstructured or semi-structured data. But in a recent year, we got a lot of unstructured and semi-structured data across everywhere, and we have this new SQL database as well. And that is where this data lake comes into the picture, where we can see that now on we can just consume the text data, image data, audio, video, all kind of data, with the same ETL process into the data warehouse. And this actually semi-structured, unstructured data is heavily being used in data science, machine algorithm on the AI side, right? Now, this data lakehouse actually combines the power and the strength of both these words and came up with this data lakehouse where you can see this architecture, which is pretty much explaining, you can consume any data, store in a data lake, and top of it, you can create your metadata or the governance layer and data modeling and whatever you want to do, and then it is ready for consumed by any tool, whether it's a data visualization, data science project, or your machine learning or your AI tools, right? So I have already published a one Medium article where I was trying to just set up this lakehouse architecture with the help of a PostgreSQL, and that is what I love to do, to explore any architecture, whether I can just implement the same architecture by using the very known and common technology. And here I'm trying to build this lakehouse kind of architecture on my PostgreSQL, and I'll explain that with the working demo so that you guys can also understand. You can go through my Medium article to understand all the detail, and really thanks for the Databricks this image because I really like this image, and I just put it in my Medium, and it is having all the setup related information like how you have to set up role Postgres. Along with the Postgres, I am using a MinIO, which is actually giving us an object storage, which is pretty much same like how AWS S3 bucket work, S3 works. So I'm just going to explain all these things, how these Postgres and MinIO is going to interact with each other. Okay, and then we have all the queries, all the data which we need here, right? So just before getting into the working demo, how to set that up, there are few prerequisites which you have to prepare, right? So what you need is you need these three files, which I can quickly show you on my PyCharm. I created this shared underscore data in my folder. Then we have this raw underscore data, and we have these three CSV, sales.csv, product.csv, and the customer.csv. All the data we have here in the CSV format. And now we're going to see how we can access the data. Pretty much same like how Lakehouse can consume any semi-structured or unstructured data and provide us a relational database like SQL query execution mechanism, right? And there are other features as well which Lakehouse provided, and I created some very high level capabilities which Lakehouse provides. the ACID transaction. Hybrid query, what does it mean? Hybrid query means you can, you know, interact with the semi-structured and unstructured data along with the structured data with writing a SQL queries. That is what I'm going to cover in today's video. In the next video, we're going to cover an ACID transaction, how Lakehouse is actually, provide the capability of ACID transaction. Then the time travel, schema evolution, which is a very interesting topic, partitioning and change data capture, which is a very, very important concept when it comes to the building a data analytics platform. Right? So let's just start with setting up, the environment, and then we're gonna see how we can build a lake house purely on PostgreSQL. So the very first thing which we need is we need to set up a PostgreSQL in the main IO. So what we're gonna do for that? As always, I'm gonna use a Docker Compose. You can also get the Docker Compose, the same Docker Compose which I'm using here in the Medium article itself, right? Okay, so just to have this up and running, I can quickly show you the Docker Compose. It's pretty much same as Postgres 17. You can just point it to the latest. MinIO is the latest image I'm using. This is the MinIO, website. You can just go there. I'm using a community version. If you want, you can use the AI store, which actually explain, how it is going to be. This is how MinIO can be used, which is a very good structure. I will explain probably in the future video. But for now, you can just understand there. You can just upload any data which is semi-structured or unstructured, and I'm going to explain you in a very brief way. So this is what our Docker Compose is. The first one is for the Postgres, and then we have a MinIO. The only thing which you have to keep in mind here, I'm just mounting the shared data because I want the CSV files to be available on the same server where the Postgres database is running. And I'm going to show you the way Lakehouse actually uses the CSV, how we can make these files available within a PostgreSQL where you can file the queries and extract the data as you need it, right? So what you need is we need to just make the Docker Compose up, right? Once we have this up and running, you can quickly get inside the PostgreSQL. Okay, so we are here. Let's quickly SQL view, and we can quickly get the name, Lakehouse user, and then we have the host DB. Then we are here. The next thing which we have to do is, since we have all those shared file mounted, which is available in the container itself. So the first thing which we have to do is we have to just create a extension. So in a Postgres, we have this file FDW, which is an extension for foreign data record. What it allows, it just gives us the flexibility to just access the files which are available on the same host machine where your Postgres server is running. So now you have created this extension. The second thing which you have to do is you have to create the server, and you are using this foreign data wrapper which you have just installed with this command, the previous command, and now you are creating a server with this. Once that is done, then you can just fire this query. If you just see what we are doing here is, we are trying to create a foreign table, and I'm giving a name as a products underscore rate. There we have product ID, product name, category, price, and the server date. And the server, I'm pointing to the same name what I have created in the previous command, data lake server. And option, I'm giving the location where this products.csv is actually run. Once you run this, you are done. Now you can query the data for this foreign table by simply running this. Now we can quickly verify whether this is the data we have, right? So we have these four fields: product ID, product name, category, and price. And we have these 5 records: laptop, t-shirt, coffee, headphone, and jeans. Same thing we can see here. Similarly, what we can do, we can just run the same command for other CSVs. So pretty much same, and you have to just make sure your create table command is having a same column name what you have in these CSVs, right? So now with this, you can just access the CSV file with the queries. Okay. So now we okay, so now we can see the data. Okay, so basically whatever the data we have in a CSV, we can just access the same data from the foreign table without even creating a table. We can access this semi-structured data. We have SQL queries, which is what the actual lake house, provide with the semi-structured and structured data, right? So now the very first thing which we're gonna cover is the hybrid query. So we are going to just combine data lake with the data warehouse, right? So what we're gonna do, we are going to create one table. Okay, this is a simple relational database table, and we are going to insert some data. And now if you just see, I am inserting a data from the sales lake. Basically, okay, so now we have a data in sales summary. You can quickly check that. Okay, so we have just got the data from the CSV to our relational table. So we have our lakehouse data lake set up along with the warehouse. And now you can quickly so we can combine the lake with the join. We have created a new relational table, upload the data from the CSV to here. So basically what we are doing with the help of the, this foreign data wrapper, we created a foreign table and we are able to upload that data into the relational table, which is our data warehouse. And now we can run any query, whatever we want. Right? So this is how you can set up a lakehouse architecture where we have a data lake, where we have a data warehouse table, and then we can just load the data the way we just consume the data from any data source into the data bricks or the fabric in a lakehouse. This is how the internal functioning is from the lakehouse architecture perspective. So all these commands you can find in my Medium article. I will just provide the link in the description of the video. That's it from my side for this video. In a future video, in upcoming videos, we're gonna see how we can, cover this asset transaction, how it is being provided, and the current travel, followed by the schema evaluation, partition, and change data capture. So if you are really interested to understand how this thing actually works in a lakehouse architecture, then just stay tuned. You can subscribe for my channel, hit the notification bell. Whenever these videos will be available, you will get them notified accordingly. That's it from my side for this video. If you like the video, give a thumbs up. If you haven't subscribed for my channel, please subscribe for my channel as well. Thanks for watching this. And as always, stay healthy, keep learning new things.